This is a skew planar antenna, or a skew planar plane antenna, or even seen it written as a skew planar plane wheel antenna. Irrespective, it's quite an interesting antenna, almost a bit of an art form, which I think is what attracted me to it. It's a little bit of an odd antenna. And it best can be described as elements arranged in a tilted or skewed plane. They typically come in two forms, either triangular or rectangular pattern, and they produce a nice, efficient radiation pattern. So they're omnidirectional, and they also, in the example I've got here, have a right hand rotation. So if you build it the opposite way, you'll get a left hand rotation. If you're trying to communicate between two skew planar plane antennas, they need to be of the same rotation pattern. Other than that, it's not that important. Now this antenna is really popular on the 5.8 and 2.4 gigahertz band for radio control enthusiasts, particularly for FPV, first person video setups, where the drone or aircraft is flown with the video downlink. So it's very important to try and minimize video dropouts in that scenario. So this antenna is quite popular because of the rotating polarization and omnidirectional characteristics. It is got quite high popularity. But it's not so popular in amateur radio circles from what I can see, but in my mind it's quite a useful antenna for satellite work, where we confront many of the same issues. So this is the antenna I came up with. It's based on an earlier version I built out of weld wire, which turned out to be quite successful, and despite being a fairly temporary trial arrangement, it actually sat up in the mast for a couple of years and was used for satellite work. So I'm confident that it is a useful aerial for that. But I've come up with a more robust version so that I can put it up there with a bit more reliability. So this is it. I'm going to describe how it's constructed and the testing. The only thing I will point out at this point is that there is some adjustment with the SWR, or matching, by adjusting the center point height along the threaded stud. You can adjust that up and down a little bit. I must introduce some capacitance into the match. Should be some parallel capacitance, and that can be useful to really fine-tune the SWR. So other than that, this is the antenna, and I'm now going to show the construction process that I used, and also some testing. This is the main element mounting plate. The antenna is designed around an end connector, so the hole in the center here is approximately 16 mil. It's a very tight fit, so that the end connector retaining nut will tightly screw in there, literally cut its own thread, and the end connector body will screw onto the other side. Now, the diameter there is really critical, and we've established that with a step drill, and then towards the end just beveled it in without going all the way through, and testing at the same time that this is going to be a very tight fit. So this it is a tight fit, and it doesn't necessarily go in that easily. Which is the way you want it. So then we're literally cutting its own thread. When it gets into the end, it will flop around a little bit, but the idea is to have it as tight as possible. Then the main body of the end connector screws on there and tightened up. Now this will be a very rigid attachment. Just have a closer look at the end connector pin and the threaded stud attachment. So the threaded stud is a 5mm stainless steel thread. So it's been silver soldered onto this copper sleeve, and this is the first time I've attempted silver soldering, and it has worked, but it is a lot of trouble. It's either a technique that I've got to develop further, or perhaps look at some other technique. But we've got it on. Then there's a small bit of copper wire soldered onto the copper, and then the pins attached to that. And that just slides in there like so. Just going to mix up some 2-part araldite to fill around the pin and hold it in position. Simple 50-50 mix. Of course, once this is in, it is never coming out. Okay, at this point the retaining nut and the hub plate are installed, and again, once done, it's not coming out, so it has to be right. Okay, we've got a little rubber grommet that we're going to push on here just to ensure that we've got this completely watertight. This is the complete end connector and hub plate assembly. The pin has located exactly where we want it, flush with the end. Beautiful. This is one of the 4 elements that's been cut and needs to be folded into a fairly unique, somewhat complex shape. The length of the element is in fact 720 millimeters in length, and we've got a jig that we're going to fold it with. So that's what we're going to do next. Okay, this is the jig for producing a consistent element for the Skew Planar plane. We're just going to clamp this in place and fold the elements. got the rough bends now. It's just a matter of massaging this into the exact shape that we want. Main thing is not to get too overexcited. Right. Continuously checking it against the jig to make sure that nothing gets overbent. There's no reason we can't unbend things, but better if we don't. $45. $45. At the other end of the elements, this is the center attachment, the active side if you like. This is a 90-degree bend. Back a bit. At the active end we need a 45-degree bend. So that's our 4 elements. So they just need drilling now and attachment to the hub. So at the point of jointing, let's get our holes lined up. So this will be pop riveted. Before we do any aluminium jointing, we've got to make sure the surface is completely clear of oxide, particularly on the side that's going to be contacted. Give that a good clean. I've been advised that steel wool is not the most ideal and that stainless steel is more suitable. However, I don't have any stainless steel wool and I've got some brass shaving, so I'm using that. Now I'm aware that brass potentially can react with aluminium, so we're going to give this a bit of a wash down before we go ahead and joint. But nonetheless, the surface does need to be cleaned. The element to be joined, so this will be the surface being joined. Aluminium jointing compound on the attachment surface. And again, we're just going to give it one quick bite, just so that it holds it in position. Line the holes up. Get the second pop rivet in. One bite. Second bite. To the ends of the element, so this is the active end, it's all been cleaned, along with the little attachment hub there. So we're just going to apply jointing compound and do all of these. Then we'll go underneath. quite awkward to get in. Let's give it the one shot, tighten it up once we've got the rest attached. Okay, that's pretty lined up, so we're now just going to punch all these home. Okay, we'll just clean this up, and I guess we're pretty close to testing. Right, we've got the Nano VNA set up. It's been calibrated to the end of the line. So we're now going to connect the Skew Planar plane wheel antenna to the VNA. So the green is the Smith chart, with the centre being the perfect match, and we're measuring SWR. Now we're measuring across a very large frequency range here, 300 megahertz to 600, so we'll just tighten that up onto the 70 centimeter band. Start at 420 megahertz. Stop 450. As you can see, we've got a fairly good SWR across the entire 70 centimeter band. So this antenna is extremely broadband. The target frequency we're looking for is around 435, 438. Call it 438. And so this is exceptionally good result. We've got the center of the Smith chart showing very little reactance. It's close to perfect resistive load. The SWR 1.15 to 1 at 438. Seems the antenna is slightly higher in frequency than I was hoping, but we are pretty much on the center point on the Smith chart, which is consistent with the SWR at being 1.08 to 1 at 442 megahertz. Gets a little bit reactive as we move down the band, but nothing of any concern. Alright, very happy with those results. I've created a model of the Skew Planar plane antenna in MMANA, a antenna modeling program. So this is what the 3D sketch of the model looks like. We run a calculation at 438 megahertz. So we're doing it over a perfect ground because it's most likely going to be over a metal roof. Yeah, perfect. So start the model, and showing good results at low SWR, some positive gain. This is the radiation pattern. Looks reasonably good. A bit of a 3D rendering of the radiation pattern. Again, looking pretty good. Whether it reflects reality, not sure. Also note that the Z-plane pointing directly up has a bit of a dip in it. May not be a problem for amateur radio antennas unless the satellite passes directly overhead. And again, whether this actually reflects the true performance of the antenna. So I'm going to finish the video at this point. I will do a second video where I will do some range testing, do some measurements on the rotating polarization and gain of the antenna, but I'll save that for a second video. So this is the video of the construction and with some testing of the Skew Planar plane antenna. Thank you for watching.